Hello friends, I welcome you in lecture number 12 on double integrals. From previous lecture we have discussed that how to change the order of integration in a given double integral. Sometimes we are able to integrate our integral in a given order, but sometimes they ask you to do the problem by changing the order of integration. Suppose if we consider this integral, here integral is of function which is 1. Here we have to integrate constant function 1 by changing the order of integration. Now here there is no problem in going for this order. It is easy to evaluate this integral with respect to y first and then with respect to x. But here we are asked to find out the value of this integral by changing the order of integration. So even if it is easy to evaluate in this order, we will not do this problem in this order, because we are strictly asked to find out the value of double integral by changing the order of integration. So we must have to change the order of integration. In given integral, order of integration is first with respect to y and then with respect to x. So we don't have to go in this order. We will change the order of integration and we will obtain this order, first with respect to x and then with respect to y. So as we have discussed in the last lecture, to change the order of integration we require the region of integration. So first we will write down the given information. From given double integral we will write down the limits of x and y, and then using those limits we will be able to sketch the region of integration. So here order of integration is first with respect to y and then with respect to x. So these are the limits of y and these are the limits of x. So first we write down what is given in our problem. So first we write down the limits of x and y. In given integral, y is from x square divided by 4a to y equal to x square by 4a to 2 square root of a into x, and x is from 0 to x equal to 4a. X is from 0 to 4a and y is from x square by 4a to 2 under root of ax. So therefore in given integral order of integration is we are just writing the given information. Order of integration is first with respect to y and then with respect to x, and this order is obtained by considering a vertical line. For this order we consider a vertical line. If we want to integrate with respect to y first, we know that we have to consider vertical line passing through the region. So this is given information. So from this we will get the idea that because we want to change the order of integration, we don't have to consider the vertical line. So we will consider the horizontal line passing through the region. Before that we have to sketch the region of integration. So we can see our region is bounded by these 4 curves. These two are parabolas. So first we can find out this intersecting points of these two curves. Okay, so we can obtain intersecting points of these two by taking y equal to 2 under root ax in this y equal to x square by 4a. So first we find out intersecting points. So putting y equal to 2 times under root a into x in y equal to x square by 4a. we get, so here we put y equal to 2 under root ax, this is equal to x square divided by 4a. So if we take this on this side, it is 8 times a into square root of ax equal to x square, and if we take square on both sides, we have 8 square, that is 64 a square into ax equal to x to the power 4. So this we can rewrite as 64 a cube times x, this is going to be a cube, minus x raised to 4 equal to 0. So here we can take x common and we have 64 a cube minus x cube equal to 0. So either x is 0, and another possibility is 64 a cube minus x cube equal to 0, and this will give us x cube equal to 64 a cube, that is cube of 4a. So from this we obtain x equal to 4a and x equal to 0. So now we can find out corresponding values of y. When x is 0, y will be 0, and when x is 4a, we can put x equal to 0 and x equal to 4a 1 by 1. If x equal to 0, y is 2 times under root a into x, that is 0, that is going to be 0. And if x equal to 4a, y equal to 2 times under root a into 4a, so this is going to be 2 times square root of 4a square. Okay, this is 4 into a square. So here we have square root of 4a square is plus or minus 2 into a, that means y is equal to plus or minus 4a. But here y equal to minus 4a is not possible, because we can see here we have y equal to x square by 4a. We have one equation as y equal to x square by 4a. So if we consider y equal to minus 4a, we will have minus 4a equal to x square by 4a. So that will give me negative of 4a square, that is x square is negative, which is not possible. So we will not consider negative value of y. So we will consider only y equal to 4a. So here we can write y equal to minus 4a is not possible because of this curve x square equal to 4a y. So this will become negative if we consider y equal to minus 4a. So therefore intersecting points are of given parabolas are, when x is 0 we have y equal to 0, when x is 4a we have 4a, and of course here a must be positive. If it is not given to be positive, we consider a as positive. And similarly we can decide the intersecting points of these two. If I put x equal to 4a here, I will have y equal to 2 times x is 4a, so this is going to be 4a square, that is 2 into 2a, we consider only positive square root, so 4a. So these two will intersect at point 4a comma 4a. If we talk about this these two, y equal to x square by 4a and x equal to 4a. So if we put x equal to 4a here, we have y equal to 4a square divided by 4a, that is 4a. So these two will also intersect at this point, 4a comma 4a. So now we are able to sketch the region of integration, and we have these two parabolas. So first we sketch the coordinate axis, x-axis and y-axis. This is x-axis, means y equal to 0, this is x equal to 0, and suppose this distance is 4a. So here also we have to approximately consider, suppose this distance on x-axis is 4a. So this is the point 4a comma 4a. So we can first sketch the line x equal to 4a, which is passing through these 2 points. So approximately we have to sketch all the curves. Okay, it should look like a straight line, but this is fine. Suppose this is the line x equal to 4a, and these points are 4a comma 4a and 4a comma 0. Another curve is x equal to 0. So x is from 0 to x equal to 4a. Now we have y equal to x square by 4a and y equal to 2 under root ax. Y is x square by 4a, y equal to 2 under root ax. So if I square this, it is y square equal to 4ax, and here because a is positive, this is parabola in this shape. So y square equal to 4ax is the parabola passing through 0 0 and this point. Okay, so first we sketch that parabola, and it will pass through this point also, because it is symmetrical about x-axis. It must pass through this point also, which is symmetric to this point. So now we have to roughly sketch the parabola y square equal to 4ax. Okay, it should pass through origin and this point, and here we have to be careful, it will pass through origin only, and then here it will pass through from this point. Okay, here we must have smooth part, okay, because this is a smooth curve, so it should look like arc, it is not a straight line. So this is the parabola y equal to 2 under root ax. Now we sketch this one, y equal to x square by 4a, that is x square equal to 4ay. So this is here also, this is a is positive, so it will open in upward direction and it will pass through these 2 points, 4a comma 4a and 0 0. So now we have to sketch this parabola. Okay, so it should pass through somewhere here also, because it is also symmetric about y-axis. So we can just have the rough sketch. It will be parabola passing through origin and this point. Okay, it should be like this. Okay, so this is just a rough sketch. So suppose we consider this, it is y equal to x square by 4a. Now our region is in between these two parabolas, and it is from x equal to 0 to 4a, and y is from x square by 4a to y equal to 2 under root ax. So y equal to x square by 4a, means this lower boundary, this is y equal to x square by 4a, and this is y equal to 2 under root x, and x is in between 0 and 4a. So this is the region of integration. Region between two parabolas between x equal to 0 to x equal to 4a. So this is our region of integration, and here in the given integral, order of integration is first with respect to y and then with respect to x. So that order is obtained by considering vertical line. So to change the order of integration, we have to consider a horizontal line passing through the region of integration. So here we consider horizontal line passing through the region. We can consider horizontal line passing through any part of the region. Here suppose this is the horizontal line, then we can see line enters the region at this point, which is on this parabola. So if we consider line in any part of the region, it will enter on the same curve. Similarly, line will leave the region on this parabola. So now we decide the value of x at these points. On this part of the line, y becomes constant. So now we have to decide values of x at this point where line is entering and value of x at this point when line is leaving. So here this point is on the curve y equal to 2 under root ax. So if we square on both sides, we have y equal to 4ax. So from this we obtain that x is y square by 4a. X equal to y square by 4a. So line enters at x equal to y square by 4a, and this point is on this parabola. So here we have to decide value of x. So from this we obtain x square equal to 4ay, and therefore if we take square root, x will be equal to plus or minus square root of 4ay. From this we obtain x equal to square root of 4ay, either positive or negative, but at this point value of x is positive because it is on the right side of y-axis. So we consider only positive value of x. X is square root of 4ay. So limits of x are from x equal to y square by 4a to x equal to square root of 4ay. Now to decide the limits of y, we have to consider lowermost point of the region and uppermost point of the region. So origin is the lowermost point of the region. At origin value of y is 0, and this point is the uppermost point of the region. At this point value of y is 4a. So y is from 0 to 4a. So now we have to write all these things. First we write that to change the order of integration, we consider a horizontal line passing through region as shown in figure, and then we write down the new limits of integration. The new limits of integration are limits of x are from y square by 4a to square root of 4ay, y square by 4a to square root of 4ay, and y is from 0 to y equal to 4a. So therefore order of integration is now first with respect to x and then with respect to y. So therefore our given integral which was x square by 4a to 2 under root ax, x is from 0 to 4a dy dx. So after changing the order of integration, this integral is equivalent to this integral. Instead of dy dx, now we write dx dy. Limits of x are from x square y square by 4a to square root of 4ay, and y is from 0 to 4a. So these are the limits of y, these are the limits of x. So this is the equivalent integral obtained by changing the order of integration. Now we integrate with respect to x first. So as we know here, this is inner integral. While doing this integral, we will consider y as constant. So integral of 1 with respect to x is x. So first we consider integral of 1 with respect to x, and limits of x are from x equal to y square by 4a to square root of 4ay, and after putting limits we will integrate with respect to y from y equal to 0 to y equal to 4a. So now we put values of x. Y is from 0 to 4a, upper limit is square root of 4ay, lower limit is y square by 4a, and we have to integrate this with respect to y. So now here square root of 4a is constant. Integral of square root of y, or we can write one more step, y raised to 1 by 2 minus y square by 4a, and then we have to integrate with respect to y from y equal to 0 to 4a. So this is now square root of 4a. Integral of y raised to 1 by 2 is y raised to 1 by 2 plus 1 divided by 1 by 2 plus 1, that is y raised to 3 by 2 divided by 3 by 2, and if we take this in the numerator we have 2 by 3 times y raised to 3 by 2 minus integral of y square is y cube by 3. So this is going to be 3 into 4a, that is 12a, and then we will put y is from 0 to 4a. So now we simplify this by putting limits. If we put y equal to 4a, and this we keep this as it is, 4a to here 3, y is 4a raised to 3 by 2, here 4a raised to 3 divided by 12a, and for lower limit we will have 0 because y is in the multiplication. So now we just have to simplify this. So 4a raised to 3 by 2 means square root of 4a raised to 3. So that we can write as 4 square root of 4a raised to 3. So we rewrite 4a raised to 3 by 2 as cube of square root of 4a, so that we can combine these two, and this is going to be 4 raised to 3 into a cube divided by 12a. So this is now going to be 4a raised to 1 plus 3 that is 4 divided by 3 minus here we can rewrite this as 4 into 4 into 4. Here 1a will cancel out, and here we rewrite 12 as 3 into 4. So square root of 4a raised to 4, that is square root of 4a square raised to 2. So this is going to be 4a. So here we have 4a square divided by 3. Here 1 4 will cancel out, and this is 16a square divided by 3. So now this is nothing but 2 times 16a square divided by 3 minus 16a square divided by 3. So 2 times 16a square by 3 minus 1 times 16a square by 3, that is 16a square divided by 3. So in this way we can obtain the value of double integral by changing the order of integration. So what we have to do is, first we have to write down the given information. From given limits we will be able to sketch the region of integration, and after sketching the region of integration we have to consider horizontal line if order of integration is in the given integral is with respect to y first. We will reverse. If order of integration is with respect to y first, then we will do the problem by considering horizontal line, because we want to change the order. And if order of integration is with respect to x first in the given integral, then we will consider vertical line to change the order of integration. So this is all about today's lecture. I hope you like this lecture. Thank you very much.